Hello! Denmark land. It's wonderful to be here. Has everyone had a fantastic week? Yes. Excellent. Glad to hear it. I would just like, before I start, to say thank you to Jacob and Kirsty and Steiner and Henriette and all the volunteers, the people in the green t-shirts who've been sort of marshalling the rooms and gathering the feedback and everything. There's a lot of work that goes into these conferences, so can we have a round of applause for all the people who make this happen? So I'm going to finish things off. You're all tired. It's been a long week. You've got loads of information to process. And so I'm just going to basically share some very silly stuff. There may accidentally be some lessons in there that you can learn. I apologize. But this is all about some mistakes and the kind of mistakes that are made by software developers and engineers. Before I start, content warning, there is going to be swearing. I am going to say fuck quite a lot just in the next segment, but it is relevant to the plot, and so that is justified. What I am not going to be talking about in this talk, because it's light-hearted, it's designed to make you laugh, I'm not going to be talking about any situations where software errors have actually killed people. But software errors have killed people, okay? So, yeah, but there's none of that in here. This is all just, it basically cost a lot of money for the most part, or cost me my job in what some cases. So, yeah. And this is me. This was one of my biggest mistakes. I worked for a software company, and this was when I was in my 20s. I was young, I was arrogant, I thought I was like a 10x developer and hot shit and all that sort of stuff. And I worked at this company, and also, in my defense, before we get into this, I was already spiraling into what would eventually become a full-on nervous breakdown. So I wasn't necessarily thinking straight. Our company, we sold event management software and membership software, and it was very complicated, and you could build these huge complicated queries across the database, and you could save those queries into a file so you could load them again the next day. And those files had a MED extension. I can't even remember what it stood for, but we called them MED files. And we released an update to the software, and it corrupted. When you saved the MED file, it corrupted it. And so the support people came to me, and they said, and I quote, "Mark, the MED files are fucked. Can you write something to unfuck the MED files?" And so I went into Visual Studio and I did file new project, and it said, "What's the project name?" And I went, "Oh, unfuck." And so I created this little Windows application, Windows Forms application, and it displayed a dialog box, and it said, "Choose file to unfuck." And you clicked a button, and you went off and you browsed and you chose your file, and then it had a button that said, "Unfuck now." And then it ran it through its thing, it did its thing, and then it displayed a message box that said, "MED file successfully unfucked. Close." And it worked. Well, I thought it worked, but you know, support were also QA. It was that kind of company. And so I gave the application, which was called unfuck.exe, to the support person who had reported this to me, and I went, "Can you test this out and make sure it works, and then we can clean it up and send it to the customer?" I don't know if he tested it. I can't imagine that he did, because then without coming back to me, he shipped it to the customer. And they ran it. And yeah, it doesn't look particularly. These are the kinds of customers who are paying you £500,000 a year on a sort of support subscription basis. And we send them a file called unfuck.exe that says your file has been unfucked. And at the time, I was in such a bad place mentally, I blamed the support guy for this, because I obviously got hauled across the coals for this, and I blamed the support guy for shipping the thing, whereas obviously it was actually my fault. I should never have created a program called unfuck.exe. That was just not a good idea. It's okay to swear in comments, as long as you're never going to open source things, but don't actually put unfuck. On a slightly related note, by the way, very early in my career, did any Windows 3.1 veterans in the room? So Windows 3.1, it was a file called win.com, and every message and every piece of text that could be displayed in Windows was embedded in win.com just as text. And if you used a hex editor, you could open it up. Interesting trivia, the phrase general protection fault has one more character than the phrase Mongolian clusterfuck. And so if you put 2 spaces in the middle, you can edit someone's win.com file and then you can run away. And then the next time that happens, they will get a message box that says a Mongolian clusterfuck has occurred, which has caused your application to terminate. One of the worst things about Windows 11 is you can't do that anymore. Okay, let's talk about Y2K. Everyone knows about Y2K. That was probably one of the biggest mistakes in software. But it wasn't that we let that happen in the first place. It was really to do with how slow we were in fixing it. Because what you have to understand about the people who wrote the code that then caused the Y2K problem was that this is what data was stored on at the time, punch cards. So every column on there is basically a byte of information. And so those extra 2 digits on the year would have been an extra 2 columns on there. Multiply that by 1 million bank customers and 100 million transactions a day, and those extra 2 columns add up to a lot of extra punch cards. And memory in those days, this was what memory looked like in those days. This isn't under a microscope, this is just a photograph. That is core memory. And it's lots of magnetic poles, and through each pole, 2 pieces of wire have been passed. These were made by usually women with microscopes and needles. Memory in the 1950s was knitted. And core memory cost about $1 a bit. So a byte of memory would cost you $8. You think, like, that means a kilobyte of memory would cost you $8,000. So memory was really at a premium. And this is also, incidentally, why Unix still says core dump to this day. It's because it was the core memory that was being dumped. And of course, in those days, it was just a kilobyte, and it was quite easy to read through. So early programming languages like COBOL, they didn't think in bytes, they thought in bits. And so this is the definition for a date variable. And we say this is it's a string type variable, but the 9 means it's a number character. And so it can only be 0 to 9 or some of the other like hyphen and comma and dot and things like that. So that would fit in 6 bits instead of 8 bits, which meant you saved a couple of dollars every time you were putting one of these things into memory. So it was quite reasonable to shorten the date and only use the sort of decade and the year. This is, I've forgotten his name, Bob Beamer. And Bob Beamer in 1954 was the guy going, I realize we have to do this, but as soon as memory becomes cheaper, we really should change that to a PIC 9.8, because this is going to cause a problem. 1954, he said that. In 1964, he started saying it with a little bit more emphasis. In 1974, he started shouting about it. In 1984, he was giving talks at conferences going, guys, we really, really need to fix this. In 1994, after Bob Beamer had retired, we actually started work on fixing it. And by that time, all this software had carried on, so you wrote new bits of this software and you carried on using that. And so the effort to stop the Y2K bug from happening was ridiculous, and it took an awful lot of people, an awful lot of time. But we did it, And then the year 2000 came, and there were very few big computer crashes, and no aeroplanes fell out of the sky and all this sort of stuff. And the whole of the rest of the world went, well, that Y2K thing was a lot of nonsense, wasn't it? What a fuss. And people like me, who'd rewritten COBOL systems in Infomix 4GL to fix this, went, no, you're welcome. Yeah, thanks to me, your hospital still works, but no. Bob Beamer died in 2004, so he did actually get to see the problem being fixed. But the estimated cost of fixing the Y2K bug goes from, some people say $300 million, some people say $300 billion. Some people say $800 billion. So let's put it somewhere in the middle. We'll say it cost $500 billion to fix the Y2K bug. And you'd think we'd learn from that and we wouldn't set ourselves up for any other Y2K bugs. Particularly if you're like one of the biggest software engineering companies in the world, you wouldn't put something into, say, your flagship email server that was going to break at a... No. Microsoft, this happened this year. A thing that Microsoft was storing in an integer ticked over. I don't know exactly what the number was, but suddenly we couldn't convert this number to a long because it was too big, and Exchange servers all over the world, including Office 365, just choked and died, and Microsoft had to hurriedly roll out a fix for that. In the year 2038, there's the apocalypse is coming. Unix still stores the system date and time as the number of seconds since January the 1st, 1970, in a signed 32-bit integer, and that's going to crash in 2038. And you'd think, well, that's an easy fix. Change it to a 64-bit integer, but no, they've patched it with an extra bit. So now they've got a 33-bit integer, which kicks the can down the road until like the year 42 something. But, you know, Linux gonna Linux. My favorite one of these, though, is the Dog38 bug that the Kennel Club of the United States of America have. So the Kennel Club, your dogs are categorized by their pedigree breed, and then your dog has a name, and it's one of those big, long show names, like I have a pedigree dog, and I can't remember her show name. It's got something sugar cookie, something, something. And so if they already have a dog with that name, which is obviously a big country, 300 million people, lots of dogs, it happens. And so they number them and say, 1, 2, 3, 4, 5, 6, blah, blah, 37. And if you go to add a dog, and there are already 37 dogs of that breed with that name, and so this is dog number 38, it crashes because it can't write the number into the database. See if can anyone guess how they're writing the number into the database that would cause 37 and all the numbers up to 37 to be okay, and 38 suddenly crashes? Roman numerals. They store the Roman numerals in a char6 field, and every number up to 38, so 38 is XXXV, 37, sorry, is XXXVII. All the numbers before that fit in fine, but 38 is XXXVIII. And this one, I really don't understand. It's go into the database, change it to a char8, or, God forbid, an integer, and just format. Someone just went, I can't write the algorithm to format a number as Roman numerals. Let's just store it as Roman numerals. So yeah, that's fun. I would like to thank Stand Up Maths on YouTube, great channel, and I found that one on there as I was writing this talk, so that was interesting. A lot of this actually comes down to one of our biggest mistakes in programming, which is just enterprise programming generally, enterprise software. It's just, the processes and the procedures and the waterfall and the project planning 5 years in advance and all this sort of stuff. And it causes problems. And you can see the kinds of problems that it causes. So yes, enterprise, a business plan or project, especially one that is difficult or may fail or lose money. And everything in enterprise development is based around this. It's nothing to do with building good software. It's nothing to do with working efficiently. It's all to do with covering your arse so that when the thing goes wrong at the end of the day, you still get paid because you can prove it was somebody else's fault, which is why you get agile development posters that look like this. This is the scaled agile framework for enterprise. This is the simplified version. There are worse versions than this. And you get things like this, Auto Scrum 1.1, which is Accenture's. This is still claiming to be agile. This is Accenture's agile framework that they use. And somewhere in there, we have a program backlog. We got a we have a sprint right down there. There's a daily scrum, and I think they've allocated some time for people to write code, but I'm not sure. People have probably seen this. This is Deloitte's Agile Landscape version 3. The terrifying thing with this is that this and this are just single dots on this. and we wonder why so many enterprise projects fail. Quick story about enterprise. I was hired by one of the national agencies, the Quangos, as we call them, quasi-autonomous non-governmental organization. In the UK, they had an API endpoint, only had one thing, and it just returned a list of the amount of energy that was being used in the UK right at that second. And that is very useful information if you're investing in energy futures. You want to watch those patterns. And so people just kept hitting it and hitting it and hitting it. It didn't have IP throttling. It didn't have any accounts or anything like that. It was an anonymous endpoint, and you hit it, and it did a quite complicated database query against an Oracle database. And did people put a thread.sleep 10 or a task.delay 10 in between? No. No, they just get it, hit it again, hit it again. They had this running on one 32-bit server. It was written in .NET 2.0. I'd been brought in to look at this in 2014, it was 32-bit .NET, so it didn't have much memory. The Oracle database was also 32-bit, running on an old server. The servers had been there since like 2005, so they were well past their death time. And they said, can you take a look at this code and tell me what's wrong with it and tell us how to fix it? And I went, I could just fix it. And they went, no, don't fix it. We give you 2 weeks to write a 20-page document telling us how to fix it. And so I took it back to the office and I loaded it into Visual Studio, and ReSharper actually started crying and then uninstalled itself. And went, no, you're on your own. Just don't. And basically, I don't do planning, I don't do documentation, I don't do that sort of thing. I'm getting better at it now as I get older and more responsible. But back in those days, I was kind of like, what I'm going to do, I'll fix it, and then I'll just write down what I did to fix it. And actually, the main thing I did to fix it was where they said var connection equals Oracle database connection, new Oracle DB connection, I just added using, because they weren't disposing their database connections. So it crashed every 20 minutes because they exhausted memory, and the app pool had to recycle. And so I managed to write 20 pages on why using statements are important, sent it back to them, didn't hear anything from them for 9 months. And then they came back to me and they said, can you come in for a meeting to discuss your findings? And I'm kind of like, you haven't done it yet? So I go up and my boss goes up, and he's charging them £2,000 for me to be there for the day. Lord knows what he charged for him to be there for the day. I'm guessing about £5,000. We get there, there's 10 IBM consultants sitting around this table. And I know that IBM consultants are about £10,000 a day. So this is a £100,000 meeting that's happening right here, and And I go, look, I can give you the code. I've brought it on a USB. If you want the fixed version of the code, it's here. And I would recommend running it in 64-bit on a server that isn't 10 years old, but this will probably still work even if you don't do that. And they went, yes, we can't just go in willy-nilly and fix it and put it on new servers. This is a critical system. I go, yes, it's a critical system that crashes every 20 minutes and is costing you an absolute fortune. And just buy a new server, just put it on a new server and it will be better. Give it 64 bits and give it like 16 gigs of RAM and it will run smoother. Well, we can't just, that has to go through a whole process. And I'm like, this meeting is costing £100,000 and for £100,000, you could buy a data center and run this thing on a server farm and it would be fine. And my boss went, Mark, why don't you go outside and get some fresh air? And so I go out and I wait by his car and he's kind of, I'm just like, I'm in so much trouble, I'm going to get sacked again. And I'm smoking a cigarette because I smoked at the time. And he comes out and I'm like, I'm really, really, really sorry. And he went, no, don't worry about it, I'll tell him to fuck off. We don't need that shit, he said. Okay, this was a fun one. So problems in software, they're easy to fix. So you ship some software that doesn't work, and they go, oh, it doesn't work, and you go, here's a new version of the software. Intel managed to get a software bug into their processor. So the PENTIUM chip was the first Intel processor that actually had a floating point unit built into it. Before that, we had the 486, and there was a 487 coprocessor that did floating point. But Intel had combined it into the actual chip itself. And the PENTIUM floating point unit accelerated floating point operations. There you go, that's what it looked like. So, what is 4,195,835 divided by 3,145,727? It's 1.33382. Except according to the Intel Pentium's floating point accelerator, it's 1.33374. And there were a few instances where this would go wrong, and people noticed. And Intel went, okay, if you can prove that you are actually affected by this bug, we will just send you a new Intel Pentium processor where it is fixed. And then so many people came up with these torturous, this is why it's not working for me, which were largely to do with Microsoft Excel. And so Intel ended up going, fine, just if you've bought a Pentium, we'll send you another Pentium. And that ended up costing Intel $475 million to fix. I'm not sure anything like it's happened since. I would imagine they probably run every possible floating point calculation as part of their unit tests. Null. This is quite famous. Null, and we actually have a fairly easy value to assign to null because Tony Hoare, who was the guy who invented null, has called it his billion-dollar mistake. So Tony Hoare, he's a British computer scientist, hugely respected. He's like a knight or a KBE or something of the British Empire. And he was working on Algol W. And Algol W was the first programming language that introduced the concept of records, what we think of as like classes or structs or whatever. And so you had a record that was a person, which had these things in here. And so when you've got records, you need references to where that record is held, because now it's a collection of data stored on a heap. And so you can see here, person has a reference to another person, which is their father, mother, youngest offspring, or elder sibling. And so where you've got references, what do you do if there is no father, mother, youngest offspring, or elder sibling? And so Tony Hoare went, well, we'll just call that null. And so we say if P equals null, then M, otherwise if M equals null, then P, otherwise do something with P and M, and we'll return that back. And at the time, that probably seemed perfectly reasonable. But ever since then, hands up who has not ever had a null reference exception in .NET or Java or any language they've ever programmed in, or JavaScript, undefined does not have a method index of, or whatever it is JavaScript says. So yes, and Tony Hoare calls that his billion-dollar mistake and will quite happily tell you all about it. There's a video on YouTube of him doing a 1-hour talk at a conference about how null happened and why it was a bad idea. Hartford Center. Sometimes software problems actually cause other problems in the real world. So the Hartford Center was built in the 1970s, and it was one of the first buildings that was designed using a software CAD package, a computer-aided design package. And back in those days, there was no AutoCAD, there weren't these high-level things. A CAD package, the engineer and architect using it would actually program in the algorithms, the formulas for the stresses on various beams and all this sort of thing. And they built the Hartford Center, and it was fine, but the Hartford Center, I think it's in Connecticut, or it's somewhere in the United States, it snows. It snows a lot. And the Hartford Center was fine until one night it snowed a lot, and this happened. Fortunately, no one was in the building at the time. There had been a concert, and everybody had left the building about 4 hours before this actually happened. And the problem was that they'd put in the calculations for the beams on how much the stresses on them were going to be, but what they didn't account for was that the roof is slanted like this. And you people in Scandinavia, you'll know what happens to snow when it lands on a roof. It kind of evenly distributes itself like this, and then it warms up a bit, and it goes boom. And they hadn't accounted for the horizontal tolerances on these beams. And so it did that, and a beam sheared sideways, and then that beam sheared sideways, and then the entire roof collapsed just because of one error in programming a CAD package. That cost them $90 million to put a new roof on the Hartford Center. That's not too bad. This one's fun. Knight Capital. I like this one because Knight Capital are a hedge fund, and I don't like hedge funds. Although if you work for a hedge fund and you need some consultancy, I will happily come and consult for you, and my rates are very reasonable by hedge fund standards. Certainly compared to Knight Capital. What you have to understand about hedge funds is the stock market. The first stock market was created by the Dutch East India Company. They needed to raise money to build ships to go to India to steal stuff and bring it back to Europe to sell it. And so the way they did this was they said, we'll sell shares in the expedition, and then we go and we steal the stuff and we bring it back here, and then we sell it, and then you get your percentage of our profits that we make from doing that. And then other people went, that's a brilliant way to raise money to start a company. I'm going to do that as well. And then 400 years later, somehow that had turned into highly optimized programs running in dark pools, trading with each other at microsecond levels, skimming fractions of a cent off the top of the transaction to try and make rich people richer while the rest of us got poorer. And this is what Knight Capital were doing. And in 1996, this was all happening in these things called dark pools. So the hedge funds and the investment banks and everything created their own sort of shadowy stock markets where they could do this. And the New York Stock Exchange went, we are missing out on so much commission. We're going to create our own light pool. And so they did, and they called it the Retail Liquidity Program. And so everybody had to scramble to get their algorithms and their programs that were running in the dark pools to run on the New York Stock Exchange's Retail Liquidity Program. And so Knight Capital basically copied and pasted a bunch of code around the place and dragged in some modules and all this sort of stuff and threw it into this new retail liquidity program with about 2 weeks' notice. And it went in there and it started running, and within 4 minutes it had spent $1 billion. And when they deployed it, it was running on 8 servers, and the deployment rolled out, but it only worked on 7 of the servers, and the 8th server continued running this old code that was the buggy code. And so they went, oh no, it's spending too much money. A failsafe that was supposed to trigger wasn't working because it came from a different system and the flag wasn't getting set and whatever was going on. And they went, well, it must be that this new code has got a bug in it, so we'll roll it back. And they said, copy the code from the 8th server onto the other 7 servers, that'll fix it. By 28 minutes past 9 on the morning that this thing went live, their algorithm had spent $7 billion. And Knight Capital didn't have $7 billion, and the rule is you have to settle within 48 hours. And so they had to essentially bail themselves out. So they sold all their positions, this entire $7 billion worth of positions, to Goldman Sachs for $450 million. $440 million. So yeah, and then the following year they were acquired in a hostile takeover by Goldman Sachs, who kind of went, yeah, you really shouldn't be allowed to do things. That's fun. I like it when hedge funds lose money. How are we doing? Halfway through. Good stuff. So, bugs in space. Like pigs in space from the Muppets, but bugs in space. There have been lots of bugs in space, and bugs in space are difficult because you can't sort of attach it. You can't go, how is this going to work in space? I know, I'll go into space with my laptop and set a break. You can't do that. Laptops don't do well in space for a start. So yeah, so just a few of these. Mariner 1. This was one of NASA's very first missions, and the computers in those very, very basic, and so programming was taking mathematical formula and turning them into machine code. I don't think there was even assembly language, really, for these guys. And so they would take the mathematical formula and literally kind of just go, okay, so that would be this and this and this. And this is what Mariner 1 would have looked like if it had ever made it to space. But it didn't. And it wasn't the programmer's fault, it was the mathematician's fault. He gave the programmer a formula that had an R in it. And it should have been the R on the left with a hyphen over the top of it. And what the hyphen means is smoothed over a period of time. So we sort of, it's going to spike up here and down here and down here, but what we want is kind of the average over the previous like 20 samples of whatever this is. But he just left out the hyphen, and so they used R. And so if you've got a value where it's supposed to be 0 and kind of +1 or -1 is probably okay, +2, -2 is probably okay, but +8 is a very bad idea indeed. And you're not smooth, you know, so 8 and then back down to 0, and then -8 and back up to 0, it's probably okay, that's probably normal. But they thought what they were getting was the average smoothing. And so when it came through as 8, the guy in mission control went bang and hit the button that blew up the rocket on purpose. So, yeah. If anyone was in Martin Thwaites' talk on open telemetry or any talks about tracing or metrics or anything like that, it's really important to make sure that the data, your telemetry data, is accurate and that you're getting out the number that you think you're getting out, because otherwise you blow up your spaceship and then you have to build another one for $18 million in 1960s money, which is closer to $80 million today. You think, actually, the Mariner 1 mission is credited, that missing hyphen is credited with the creation, the inspiration of software engineering as a discipline. That was the point at which people went, hey, maybe we should do like what those engineers do when they build bridges. And, you know, bridges have collapsed and stuff, but that was when we kind of started applying engineering principles to building software, which did not save the Mars Climate Orbiter. Which had a similar experience, although it did get most of the way to Mars. To be fair, the rocket took off, it got it into orbit, it set its engines going, and it got to Mars, and then it crashed into Mars. Crashed into the surface of Mars at a very, very high velocity, and there's still a scar that you can see from one of the other orbiters that went up there. And the reason for this is incredibly simple. It's because Americans are stupid. And Americans insist on using inches instead of centimeters. Now, NASA are not stupid. NASA use centimeters for everything. Actually, they use millimeters for everything. So NASA is like millimeter scale stuff. So they don't say a centimeter, they say 10 millimeters, because they work with the European Space Agency, they work with Roscosmos, they work with the Chinese, they work with space agencies all over the world. They work with suppliers all over the world. You have to be using the same units. And everyone on the Mars orbiter mission was using the same units. Everyone was using millimeters and centimeters, except Lockheed Martin. Lockheed Martin were using inches. So to give you a visual idea, if this is me at 5 centimeters tall, then this is me at 5 inches tall. It's quite a big difference. Inches are not centimeters. And so when the Mars Climate Orbiter arrived at Mars, its planned trajectory was that it should have gone into orbit at 226 kilometers above the surface of Mars. And what it actually did was go into orbit 57 kilometers above the surface of Mars, which meant it got caught in Mars's gravity and smashed into it. So yes, units are important. It's one of the good things about F# is the whole units of measure thing. Could we get that in C# 12 or something, Mads? You know, you're copying everything else from F#, so. So awesome having him in the room to say that. Yay! Okay. It's not just NASA, though. So yes, £327 million. For the Mars Climate Orbiter, plus the 18 months that it takes the thing to get to Mars, and then kind of going, that didn't work, should we build another one? Yeah. But the European Space Agency has problems of their own. This is the Ariane 5 launch. And Ariane, this is the first ever launch of Ariane 5, and it was a mission called Cluster. It had 4 European Space Agency satellites on it. And the tests had all gone perfectly, the pressure testing and everything, and then it took off and it soared majestically into the sky, and then some code that they had copied and pasted from the Ariane 4 control software tried to write a 64-bit floating point number into a 16-bit integer variable. And this caused the boosters on one side to adjust their horizontal thrust a lot. And so the boosters split off the rocket, and that happened. And yeah, this was spectacular. There's a talk kind of similar to this one by Kevlin Henney, where he goes into a lot more detail and he has the code, and it's on YouTube, so you can track that down if you want to know exactly what happened there. But basically, they had 7 variables that controlled the flight path to get into orbit, and 4 of them were guarded. So if you tried to write the wrong wrong type of data into them, you wouldn't be able to. The one there that caused that wasn't guarded, because guarding a variable uses quite a lot of something, and they didn't think they could spare it. And so, yes, spectacular. Ariane 5, though, I mean, you know, since then, Ariane 5 has been an absolute workhorse, and it's put so much stuff into orbit, and it's going to have to keep doing it for quite a while, because Ariane 6 has just been delayed again. Enterprise. $500 million, the Ariane 5 disaster. That's kind of probably exaggerated, but yeah, it's sort of including missed missions and people saying, oh no, you're not launching our satellites, we're going to take these to NASA, you can sod off. So yes. The big rewrite, this was me. This is another one of my mistakes. Same company with the Medfile unfucker, actually. We had a product that was written in a language called Gupta SQL Windows, and it was dying. And I was, can we rewrite it in .NET, please? I've got this new .NET thing, it's brilliant, can we rewrite? And they said, yeah, all right. And so I started rewriting the entire application as a Windows Forms application. And they had 4 people working on the old application, and me working on the new one. And so they were adding features and doing all that, and I was trying to catch up to them. But I was getting there, and it was okay. And then 2005, 2006 came along, and Microsoft released WPF. And it was new and improved. And I was going, oh no, it's a new thing. Windows Forms is dead. WPF is so much better, and the binding works better, and the design is lovely, and all this sort of stuff. It's a shiny thing. I want the shiny thing. And so I decided that I was going to throw out all the Windows Forms code and replace it with WPF. And that did actually cause me to have a nervous breakdown and take 6 months off work. And then when I got back to work, they did a performance review, and they gave me a 5, which was the worst you could get. And I went, why? And they said, well, you just took 6 months off. So yes, new and improved. Do not just go, shiny thing, and rewrite everything because you think it looks cool. Probably it only cost them £100,000 in terms of what they'd paid me to achieve precisely nothing, but it did also cost me my sanity. And the main sort of thing I got out of it is I know not to do that again. Recursion. This is just a little bugbear of mine. I happened to read something about recursion and how recursion is a better pattern than loops. And it's a lie, effectively. Recursion is loops. It's just a different way of doing it. So if you recurse in a normal application, you will end up getting a Stack Overflow error because things go round and round in circles, and every time it pushes something onto the stack until there's no room left on the stack. And so to avoid this, there is a thing called tail call elimination, where the compiler recognizes that that's what you're doing and eliminates that tail call and makes something happen in a different way. So to avoid this Stack Overflow exception, if you look at this, this will eventually cause a Stack Overflow because this is 32-bit .NET. x86.NET framework doesn't do tail call elimination. And so the JIT just produces this code here, which calls countdown and calls countdown. And so if you call this with a big enough number, like in 32.max value, you will get a Stack Overflow exception. With the 64-bit JIT, they introduced tail call elimination. And so that produces this code, and you can see there L0014 jump, L0007. So every time someone goes, oh, recursion is a far superior and computer science-y and functionally way of doing loops, point out to them that that's a go-to. And I can prove it's a go-to because there's the same code written with a go-to, and yeah, look, there you go. We've got jump, short, LW. It's a little bit different, but it's one less instruction than the recursion version, and we do our jump, short, L07 at the end there. And yeah, so recursion can go jump in a lake as far as I'm concerned. I would like to thank Andrei Shekin, Ashmind on Twitter for sharplab.io. If you've never seen sharplab.io and you do C# development, it's brilliant. You paste some C# code into it, it'll show you the C# compiler's sort of the C# that it generates for your properties and async methods and the state machine and all this sort of stuff. It'll show you the IL that's generated, and then it'll show you the actual machine code that's generated by the JIT. It's fantastic. JavaScript. Any JavaScript fans in the room? Am I about to upset anybody? Because this really was. It was a mistake. It was one of the biggest ones. And the thing is, it was Netscape version 2, and somebody stuck their head around Brendan Ike's door and went, Brendan, can you knock up a quick language that we can stick in the next version of our browser so that when you put the mouse over an image, we can change it to a different image? All right, cheers. How long? A week. Cool. And so a week later, Brendan goes back with Scheme, basically, because if you need to implement a programming language in a week, then you write a Lisp. because they're the easiest programming language to implement. So we went, hey, look, we've got Scheme to run in the browser. And they went, oh, no, nobody does Lisp anymore. No, we don't like all those parentheses. You know what's really hot at the moment is that Java thing. Why don't you make it look more like Java? And so rather than sort of patch the holes and the problems and everything else, Brendan made his scheme look like Java, which involves changing prefix operators to infix operators and that sort of stuff. And the other thing was they wanted it to be possible so that the kind of people who were just hand coding HTML and creating personal homepages could hand code some JavaScript to achieve these effects. And so they put all sorts of things in there to try and help these developers. Like if you said, if this thing is equal to this thing, and they were two different types, then JavaScript would go, well, what if I made them the same type? And then that would work, wouldn't it? And you go, yeah, that would work. And we ended up with this absolute abomination of language. But the biggest problem of all is that it's shipped, and then people started using it. And you can't fix it. You can't fix double equals in JavaScript. So we have triple equals and bang double equals. And apart from anything else, that's wrong. So it should be bang triple equals, or I don't know. But anyway, I just think if someone had poked their head round Brendan Eich's door and said, hey, Brendan, can you create the language that will be used for 90% of all programming over the next 50 years and run on everything from SpaceX shuttles to the internet to watches to smartphones to everything else? How long? Brendan would probably have said, oh, 2 weeks. What's a smartphone? So yes, here are some JavaScripty things. An empty array equals not an empty array, according to type coercion. No idea why that is, but those two things are the same. I think it's that empty array becomes object, which is not null, therefore it's true, and not empty array, it coerces the array to 0, which is the size of the array, and then nots it so it becomes true. So that's true equals true equals true. Who can spot what's wrong with this line of code, or why it does what it does? So, in the middle here, plus, plus. So because JavaScript does type coercion, what it's actually trying to do here is b plus a plus, and then we've got this plus floating here, and it goes, well, I'm already here, so this must mean plus a. So we're doing the positive value of a. I'll try and coerce a to a number so that I can, oh no, it's not a number, so it becomes nan. Type of nan, incidentally, is number, so not a number is a number. And then we add the other array onto it, and so b plus a plus plus a plus a is banana, because of course it is. And Douglas Crockford wrote a book called JavaScript, The Good Parts. Have you ever seen the photograph of JavaScript, The Good Parts next to JavaScript, The Definitive Guide? That's I took that photograph. And I put that on Twitter, and this was like back in 2012 or something, and it got 45,000 likes, and I was like, yeah, I'm famous. But yes, the difference between JavaScript, the good parts, and JavaScript, the definitive guide is basically the DOM. It's the document object model that is the bad parts of JavaScript, according to Douglas Crockford. And he's kind of got a point, because document.all, which is all the elements in the document, is an instance of object. But if you do type of document.all, it tells you it's undefined. So you go, all right, does document.all equal undefined? And it says, no, it doesn't. And you go, does document.all equal null? And you go, no, it doesn't equal that either. You go, well, if you type coerce it, does it equal null? And the DOM goes, yeah, it does. And they can't fix it. There is code in the world that relies on that behavior. And so Java, I mean, I don't know what the cost of JavaScript is, but the fun we have with it is priceless. And yeah, I'm just quite down with that. So I would like to have some honorable mentions here. Heartbleed. That popped up a few years ago. This was a serious bug in OpenSSL, which essentially rendered the whole thing completely vulnerable to attack. And of course, OpenSSL is used by everybody: Google, Microsoft, Amazon, Facebook, Apple. Everybody uses OpenSSL. And everyone was like, how could this be allowed to happen? And that XKCD cartoon of the entire modern infrastructure of the world and a random open source project somebody in Nebraska has been thanklessly maintaining since 1996. That was OpenSSL. It was just like this one guy who was maintaining this thing that multi-trillion-dollar companies were relying on, and there was a bug in it, and none of them had thought to kind of give this guy's code a read or check it out or anything like that. And then this year we had Log4j, because it turns out that one of the things you can put into Log4j is, hey, log this call to another service, and while you're logging this call to another service, pass it some information. Again, Martin's thing earlier on about baggage. And Log4j was, so you could put something into a text field, and then Log4j would log what you'd put into that text field, except it was a URI that said execute a Java enterprise bean, there's that word enterprise again, on this other server, and just pass it all the data that we've got attached to this log while we're at it. And there is not a single Java application in the world that is not using Log4j. So that was fun, and then they fixed that one. So, I mean, that wasn't in Java, it was in a library that every Java application uses, but it wasn't in Java itself. So Java looked okay for literally 2 weeks. And then somebody looked at Java's actual in-the-box ECDSA implementation. So ECDSA is a very complicated algorithm, and it involves 3 numbers. And one number is the result of a sum, and the other 2 numbers, if you multiply the first number by the second number, then it should equal the third number. And so that was fine, but it turns out that you pass these 3 numbers along with your ECDSA token. This might be a JSON web token or a SAML token, something that you've encrypted using the ECDSA algorithm. And if you pass it in, and so you've got the numbers, I think they were P, R, and Q, P, and R. And so it's like P times R equals Q. And so if you set Q to 0 and R to 0, then it did P times Q, and does that equal 0? Yes, it does. And so literally just by sending a malformed ECDSA signature with these 2 values set to 0, you could get Java to go, yeah, that's fine. That was in the actual, that's like the base class library. That was in the JDK, but that one came along. That was fun. So we've seen some fun examples. We've seen some very, very expensive examples. I would like to finish off with one example where we basically got lucky that, yeah, programmers make all these mistakes, we're fallible, and we're sort of hubristic, and we're arrogant, and we do stupid things. Fortunately, the rest of the world knows that, and they don't trust us as far as they could spit a rat. And so the Soviet early warning system in 1985 was switched on and almost immediately reported that America had launched 5 missiles against the USSR. It hadn't. What the image recognition software running on, I don't even know what kind of computers the Soviet Union had in 1985. I'm guessing they probably involved rocks and bits of elastic, but you know, it wasn't great. But when they've launched 5, it was actually the sunlight glinting off clouds, but that was incorrectly identified as the rocket trail from intercontinental ballistic missiles. And this man, Stanislav Petrov, Lieutenant Colonel Stanislav Petrov, on the 26th of September, 1983, not 1985, was told that 5 missiles were inbound to the Soviet Union from the United States, and he should immediately launch the Soviet Union's response. He should immediately launch what turned out to be all 4 of their intercontinental ballistic missiles. And if he had done that, then the American early warning system would have seen those, and America would have launched all the Minutemen missiles that Eisenhower had built, because he thought that the Russians had 4,000 ICBMs. They didn't, they had 4, but he thought they had 4,000, so America had 5,000, and they would have launched all of them, and that would have been game over. Humanity, most life on this planet, and then in another 50,000 years, maybe there'd be a building here with a software conference with highly evolved cockroaches talking about programming's greatest mistakes. But Stanislav Petrov said, nah, I don't believe that. I'm not launching missiles based on what a computer says. It can go stuff itself. And so we did not get World War III on September the 26th, 1983, because there was a human between the computer and the missile launch system. And thank God for that, because that very nearly cost all known life in the universe. And that's how serious some of this stuff is. So yeah, think about that as you go back to work tomorrow or next week, and maybe just be a little bit more careful. Thank you very much for listening to me, and I will see you next time.